Good afternoon, everyone. Thanks for joining this session in this nice afternoon. My name's Leander. I'm happy to be your host for the next 45 minutes. And welcome to the session about lightweight Kubernetes, where we're going to be running Kubernetes on workstations, edge, and IoT devices. So as you can judge from the title, we will be hands-on. I'll be doing a live demo on a few devices. You know, live demos on conference talks is usually a bit dangerous, but hey, what the heck? It will work. I'm well prepared. So let's give it a go. Excellent. So this is me, Leander Reimer. I'm a principal software architect. I work for a company called Über. Our headquarters is in Munich. We also have a small department in Mainz. And as you can see, I'm broadcasting from the town Rosenheim. This is my hometown. And fortunately, we also have a small office here now, so I don't have to commute to Munich anymore, which is pretty cool in those COVID times at the moment. As a principal software architect, you know, I work for, large German enterprises. I'm mainly work for this large automotive company in Munich. So I'm sure you know which one I mean. And there I was kind of in the process of migrating quite a few applications from on-premise data centers to the cloud. And of course, Kubernetes is a thing there, right? Where are all these workloads are going to be run? Well, they are going to be run on AWS or Azure, we don't know yet, and probably Kubernetes as the de facto standard operator, cluster operator. I don't know about you, but installing Kubernetes in the cloud in the year 2020 is, well, relatively easy and straightforward. For most of the cloud providers that are out there, I put a few demos here for the three major ones. It's pretty simple to spin up a Kubernetes cluster. So for those of you who are on AWS, you probably know EKS CTL or EKS control. That's a CLI binary. You download it and then you say EKS CTL create cluster. You give the cluster a name. You can specify loads of options about the cluster properties on the command line. Or as usual, you specify a YAML file with the cluster definition. And I don't know, then you wait 5 to 10 minutes and you have a perfectly running stable Kubernetes cluster, version 1.18, for example. You could do the same in Azure, right? There's also a tool called AKS CTL, which is kind of, you know, a spin-off of the previous one. So you say AKS CTL, create cluster. Well, guess what? You give it a name. You could also specify the cluster definition as part of the YAML definition file. You hit enter, and a few minutes later, you have a perfectly running cluster on Azure. Excellent. And same for Google. G-Cloud container cluster create, you give it a name. The same here, you can specify loads of command line arguments to spin up that cluster. You wait 5 minutes and off you go. Kubernetes installed in the cloud. But what if you, well, have a different runtime environment, right? What if you need to use Kubernetes on real hardware? I don't know if you have installed Kubernetes on real hardware. I mean, this is a totally different thing to do that. Now, so I would argue that installing Kubernetes on fog, edge, and IoT devices is sometimes not so easy if you do it the manual way, the hard way. Here, what I show you is kind of, you have the cloud layer at the top. And maybe some of you heard of the term fog computing or edge computing. So the fog layer here is somewhere beneath the cloud layer. So where you have some gateways or fog nodes, or maybe local small data centers where you have some hardware running. And on the edge layer, what you usually have is some form of devices, temperature devices, CO2 devices, measuring CO2, measuring light, measuring wind speed or whatever. Some devices are really dumb. They only take a temperature reading. And what those devices then usually do, they send off the those readings to the fog layer, then the data is usually cleaned up, aggregated, collected, accumulated in the fog layer on some fog nodes, and then at regular intervals, pushed for further processing to the cloud layer, to some, to some data center or to your cloud provider. Now, using containers on the edge layer and mainly on the fog layer is also kind of cool, because you have container as the distribution unit of your software. So using containers and using cloud native technology on the fog layer and the edge layer does make perfect sense. But you have to do it manually. You have to install everything manually, usually on those things. And this is where I kind of came from. And what this talk today is about, how can you easily install and run Kubernetes and Kubernetes distributions on either the device or the edge layer or the fog layer. Now, here's my question for you. I don't know about you. Maybe you have, maybe you don't. Do you have a PhD in clusterology? I kind of made up that term, right? I don't know if there is a PhD in Kubernetes clusterology, but I know one thing for sure: I don't have a PhD in Kubernetes clusterology. I have a master's degree in computer science, and definitely not in Kubernetes clusterology. But I know a few people that seem to have this degree. I'll give you an example here. This is what you see here in this 19-inch rack is 10 Intel NUC Skull Canyon. They are really mean little machines. They have quite a bit of memory. They have a nice speedy SSD inside, so they're really nice and fast. And what we did here, we usually take this this Cloudkoffer, this this cluster to exhibitions. Well, when there are exhibitions, not at the moment. And in preparation of those exhibitions, what we usually have to do is we have to install this cluster. And there are about 2 people that can do that, I know of, in our company. And you have everything on here, right? You need to install CentOS 7 in that case with containerd on the NUCs. Then in that case, what you see here, it used to be a Kubernetes 1.16, Kubernetes dashboard installed, Calico networking, external DNS configured and enabled, Metal LB and Nginx Ingress, Roops FFS as a distributed file system on the cluster, a cert manager and sealed secrets operator installed. The Elastic Stack is on this one, with Elasticsearch, Kibana, Fluentd. Just for the hell of it, we installed Prometheus, Grafana, and Loki on it as well. And then for different showcases, we usually have like Istio installed, Knative, or Jaeger, Claire, Vault, Keycloak, and all those cool technologies about this. So installing this one is, it's a manual task, and my colleagues obviously did a good job in automating all this, but still the knowledge and the know-how to make all those things work together is kind of in the brains of, 1 to 2 persons. And from a project management or team point of view, I would say, that's kind of dangerous, right? I'm sure you heard of the bus factor, and so this is kind of the bus and the evil boss, and we have, no, I'm the only Kubernetes expert, please don't hit me, yeah, you evil boss. Now, hopefully and luckily, my colleague is usually taking the car and is not taking the bus. So no worries there about the bus factor, but I think you see my point. Wouldn't it be cool to kind of, have an easier way of, installing and configuring, Kubernetes on, on real devices? So the talk today is about 2 Kubernetes distributions that kind of make our jobs as, computer scientists, as developers, as software architects, whatever, a lot easier. And the first distribution I want to show you is called MicroK8s. And the second distribution I will show you is called K3s. Okay, well, let's get started then. Now, I promised you a lot of hardware today. So I made a picture. And so you see on the left-hand side, this is what I do the demos on today. First up, I have a small brother of the big Cloudkoffer you saw previously. This is my private Cloudkoffer. This is 5 Intel NUC Skull Canyons. Well, you see a small switch in beneath. So they're kind of fast as well. They're not the newest well, hardware brand. You get faster ones and more modern ones, but this one gets the job done. You know, 32 gig of RAM, Intel i3 CPU. That, you know, that's fair enough. And if you look closely, what you see standing on the switch there is well, it's 5 Raspberry Pis, version 3, compute on modules. And they stick on a mini node carrier board. So that mini node carrier board kind of gives the Ethernet connectivity to all those 5 Raspberry Pis. Then of course I have my MacBook here on the right hand side. So this is pretty much the setup I have right now here. In the chat, what you could do, of course, if you don't trust me, let me see, where's the chat? Here's the chat. What I could do is turn the camera so that you can see everything. I can't see your screen. Can you still see myself? Who wrote that? Yeah, should I turn my camera? Wait, where is it? Oh, that's a bit, it's difficult because of the screen. But trust me, I have the setup. I have the setup there. Okay, so let's continue. We don't have time for things. So MicroK8s. Well, MicroK8s, if you have a look on the website, they say something about zero ops Kubernetes. Okay, so this is a Kubernetes where the operational burden of installing it and all that is really easy. First point, it's a certified Kubernetes distribution. Okay, it passed all those certification tests and compatibility tests, and it's backed by Canonical. So that's kind of the company behind MicroK8s. So pretty big vendor. So that's pretty cool. Pure upstream, they have not added or removed any APIs. And currently, if you want to use MicroK8s, it's in the version 1.19, right? So that's kind of the latest Kubernetes version there is. It's a single package of Kubernetes, support for 42 different flavors of Linux, so pretty much for every Linux distribution, they have a good documentation online how you can install this. I think you need Snap to install the package. And you can also use MicroK8s on Mac and Windows machines if you want to. But here you need a tool called Multipass that basically runs an Ubuntu VM on your local machine. If you do that on a Mac, which I will be doing, if you have Docker Desktop installed, you kind of need to disable Docker Desktop first and just shut it down, because otherwise the VM will not start. So that's just a tip for you. It's made for developers, right? It has loads of useful infrastructure components already prepackaged, which might come in handy if you want to develop cloud-native applications and run your microservices on, right? You maybe need a service mesh or you want an ingress or whatever. So it brings a lot of infrastructure add-ons, as you see here, DNS, registry, the dashboard, storage, RBAC, Istio, GPU support if you want to do some machine learning stuff, Linkerd, Knative, Fluentd, etc., etc., etc. So it runs on the cloud, so you can install it on the cloud as well. It runs on workstations, it runs on Edge and IoT, and well, that's pretty much it. So I would say, let's start with the first demo. If you want to follow along, or if you want to try things out yourself, I invite you. This is here my GitHub repo. Clone this repository. Feel free to copy whatever you like. This is the whole demo is in here, and this is what the repository looks like. So as you can see, for MicroK8s, what I have a small demo for MicroK8s on macOS. You can spin up MicroK8s on Google Cloud if you have an account, or on AWS in that case. So for now, we start doing that one on macOS, because this is what I'm currently running. First up, if you're on macOS or Windows, as I told you, what you need to install is this tool called Multipass. So you need to go to this site here, download this Multipass binary, and do the installation. And this is basically the virtual machine management which you need. Then on Mac, what you can do is use brew to install the MicroK8s command line binary. On Windows, you either download the binary, or you, I think you can use the package manager Chocolati for it as well. So I already did that. And then on the first try, what you then do is MicroK8s install. So to save some time, I already did that, because what MicroK8s install does on first try is it will basically download all the binaries. It will download the VM image and then spin up the VM image for you. So once you've done that, so you say MicroK8s -- help, right? So this is all you have. So you have the install command, you can uninstall, you can add nodes. This is what I will show you later to create a small cluster. The Cilium client, you can enable things and disable. I will also show you this. You have the Istio client in here, the kubectl client if you need, a Linkerd client. So basically, all you do in here is interact with the Kubernetes on using the MicroK8s CLI. So if we say MicroK8s status, then let's see. So you see everything's running already. I've got MicroK8s. It is running. Here you have a list of enabled add-ons. So the dashboard is currently enabled, DNS is enabled, the ingress enabled, metric server, and so forth. So for example, if you say, well, I don't need maybe ingress, then what you could do is MicroK8s disable ingress. So this will kind of disable the ingress, and well, instead what you could do is install a different one. Maybe install Ambassador if you want Ambassador, right? So that kind of takes a while. So interacting with this MicroK8s Kubernetes installation is well, it's all done through this small CLI, right? So that's now the demo part. So let's say here, we kind of stop that in a way. Let's see, what do we say? So you see here, this is currently what's installed on this local machine. If you do not like to interact with the Kubernetes using MicroK8s kubectl, what you can always do is kind of export the kubeconfig locally, and then we kind of say this one here, right? Export kubeconfig, and then you could use the the normal kubectl. So that's pretty much it about MicroK8s. So installing is MicroK8s install. You wait 5 minutes, all done. Then you're there. What you then say is MicroK8s start. So that's already started. And if you're done, and if you want to save some battery or whatever, then you could at all times just say MicroK8s stop, and that will well, basically stop Kubernetes, stop the VM, and you're done. So I would say really developer friendly, nice and easy, no installation burden, no pain, all pre-packaged in a nice VM and a nice CLI to get things running. Okay, now of course what you can do with MicroK8s as well is you can of course also create clusters to do that. Now, because I'm a bit short of hardware, I have the other hardware here, but what we can then say, MicroK8s G Cloud, we say Terraform init, let's see, Terraform init, Terraform plan. What I will do here is create a quick 2-node cluster on Google Cloud. So you say Terraform apply, and then we wait a bit. So we say yes, BIM. And now this does take a bit to spin up, maybe 40 seconds or so. And just to show you the Terraform output. So basically what I do here is I spin up 2 instances. I spin up an Ubuntu VM in that case. And then as a startup script, I kind of already install MicroK8s with snap install on this Linux box. I create a few users, and then I enable a few plugins and a few add-ons, and then I start things. So this is pretty much all there is. Now, let's see. So let's SSH into the master IP. Let's see. Yes. So let's see if things are already working. So status, okay. Let's do that. If you have any issues, okay. So what's up here? Maybe. So why isn't that working? It looks better now. Let's see. MicroK8s is not running. Maybe it's still spinning up. That's the danger of MicroK8s start. All right, status. Well, that's the danger of doing live demos. I have a quick look on the time. Well, we're still good. We give it a bit more. Yeah, okay. It just took a bit. Okay, so on the master, it's currently running. So what I want to show you is how you can add nodes to this cluster. So let's assume this here is the master node. What you can then say is MicroK8s add node, and what you will receive is this this command here. Okay, so on the worker nodes you want to join to this master, you basically have to say MicroK8s join, and then you have to specify this join token here. So what I do now is I go into the second VM. Yes. And we copy this URL, and now we're here. Let's say MicroK8s status. Let's see if everything's good here. Okay, everything running. And what we say on this second one now is we want to join the other node. So this kind of takes a bit now, and after maybe, I don't know, 20 seconds, hopefully only, things should be working, and I have a 2-node MicroK8s cluster on Google Cloud. And same here, usage pretty simple, pretty straightforward. So I do exit here. I log into the master again. So I could say status, right? kubectl get nodes. And you see here, I have the master and the node I just joined. Right. So much for this demo. So let's go back to the slide. So that is MicroK8s. Pretty simple to use. Loads of add-ons. I really like the amount of add-ons they have, because this kind of, every useful add-on they already support that you need for, proper application development. Now let's come to K3s. That's the second distribution I want to show you. And as you can figure, K3s, what they say, it's 5 less than K3s. So it's, you know, the 8 minus 5 is 3. It's also a certified Kubernetes distribution. And this time, this one is backed by Rancher. I'm pretty sure you heard of Rancher. What they did is, well, they took a different approach. What they did is they removed all the legacy alpha and non-default features. They are removed, right? Right now, currently, I had a look, is currently version 1.18.9, I would say. And because they removed so much, it's kind of a simpler and a more slim binary. So it's super suitable for edge devices, for IoT devices, for ARM devices like you know, like my Raspberry Pis, ARMv7 for CI or workstations, and of course you could also use K3s on some VMs you spin up on Google or AWS. They have basic load balancer support. They bring a traffic-based ingress. You can also configure high availability using an external database or an embedded database. Same here. It's super easy to install, run an auto update. And the binary, it's a single binary, and it's like, you know, smaller than 40 megabytes in size. And you can install it plain. You can install K3s plain, or you use this excellent tool called Ketchup, so K3s up. So you pronounce it Ketchup, as far as I know. That comes from the OpenFast community and from the main committer of the OpenFast community. And he built this tool that kind of makes the setup of K3s on real hardware real easy. So from 0 to kubeconfig in less than a minute. Well, let's see if that works. Maybe it takes us 2 minutes, but it's really dead fast. Right, so up for the second demo of K3s. So back to our Visual Studio Code. Let's see, let's close that stuff down here. Same thing here. If you look at the repo, what I prepared is a demo for the Cloudkoffer. So my Cloudkoffer is the 5 Intel NUCs. I have prepared for you, I will not show this now, running K3s cluster on Google Cloud, and then a small demo on K3s mini nodes. And mini nodes is my Raspberry Pis. So let's start with the Cloudkoffer. So I've prepared a small README file for you in case you want to build one of those things on your own. Here is a bit of setup instructions. So this is just the basic Linux setup required. What I have running on those one is CentOS at the moment. So the official K3s installation is pretty straightforward. So basically what you have to do is, well, you need to have SSH login on those machines. So you log into, let's say, the K3s master if you want. And then it is this one single command. So you download the latest binary, and then you pipe that into your shell and let it install. And you know, within a few seconds or 1 minute, you have something running. Then if you do that on the master node, it's kind of similar to what we've seen previously with MicroK8s, the so-called node token, which you need to join, you know, the slave nodes to the master is in that file. So you need that token, and then pretty much for any node you want, for any server you want, you pretty much take that token and you do the same. You download the binary, but this time you provided the node token, so to join the minions or the nodes to the master. Now that's a bit of typing, right? We don't want to type that much. So what we can do instead is use this Ketchup utility as I told you previously. So let's see here. So you can K3s. We want the Cloudkoffer, and whoop. So K3s up. Yeah. So let's say version. So currently we have K3 up version 1.9.7.1. Okay. And what you then do is, well, let's see, the master IP of this one node should be that one. So what you can do now is K3s up install. You specify the master IP, you give it a root user in that case, and you can specify a few additional commands. Again, because I'm lazy to type, what I will do now, I have prepared the small makefile here for you. So you see here on the master, I do install, and then I say join, 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 and after that one, I should have a perfectly running K3s cluster. So let's say we say make K3s, and now we do that. So it now SSH logs into this one node, and then it checks, is the binary already there? Do I need another one? And off you go. And ta-da, we kind of have this 5-node cluster. Now you see now it's version 1.18.9. In here, I have this stable channel. Let's see if I do latest here, and then we do that one again. What you now see that it detects, okay, you want the latest channel. Previously, I had 1.18 on it. Now it detects that it needs to install 1.19. So what we're currently doing is performing a cluster upgrade. And it does exactly the same thing. Log into the master, download the latest binary, install the binary, get the binary up and running, and then kind of join, do the same thing on the 4 agent nodes, download the binary, and spin up the cluster and join the nodes. So let's see, which one are we at the moment? So that's the 4th node. And after a bit, we should have an updated 1.19 Kubernetes cluster on those nodes. It does take a while. Let's see, let's say kubectl get nodes. Kubectl get nodes. Oh, that's still the wrong one. Give me a second. Hop. So with what we say here, we do that one here, and then we should be able to do that. And ta-da, we've just upgraded this 5-node Cloudkoffer from 1.18 to 1.19. Okay, and that's it, right? Everything done for us. Now time's running. One small demo still ahead, and let's do that on my mini nodes. So remember, the mini nodes, this is what we're talking about, okay? So this is this small board containing 5 compute-on modules, Raspberry Pi 3. I've also have a makefile prepared for you. And this is, well, it's kind of the same proceedings as before, just that we do that on, well, you see, so the master is working. So we go down here, cd K3s mini nodes. Up. Right, we do that here. We make that a bit bigger. Make K3s. Now again, it's pretty much the same build file. The only difference now is that I will be installing this on the 5 Raspberry Pis and not the 5 Intel NUCs, right? So same here. And well, we'll connect. We'll be finding the release for the stable channel. Now, of course, this installation does take slightly longer, probably too long for this session today, because of course, you know, those Raspberry Pis are not that fast. They're not so super fast. And if they get warm, unfortunately, they get slower. This is what I kind of found out. I need to find a proper cooling solution for this one. But in essence, it will do exactly the same, right? As you see here, it detects, oops, there is a new version available. So it will now first download the binary for ARM. right? For ARM, this is what you see here in this downloading binary. Once the binary is downloaded, it will then, install and get things running. Okay, because unfortunately this kind of takes probably 5 minutes now, or produces an error, like in any good live demo. But trust me, it does work. I would say we kind of close things up. So thanks everyone for listening. I hope you kind of enjoyed that session. My advice is give those two a try, right? MicroK8s is slightly bigger, but it brings a lot of good add-ons. So this is kind of the strength, in my opinion, of MicroK8s, the power of those add-ons and the ease of use of installing those add-ons. And for K3s, I think the real power is that it's so light and so small that you can even install it on, not very high-powered hardware devices like those Raspberry Pis. So thanks again, and open for questions.
Hi, I already sent something in the chat, but let me repeat. I saw an age of 341 days in the ports. Yes. Is it because RTC is missing time not set properly?
No, well, this is my private coffer, and I've been experimenting with early versions as well, and I've never tore it down. Okay, so I've been constantly upgrading new version, and basically what it just said is, well, it's all those nodes are 340 days old.
I see.
Obviously not this version, right? So I think I started with, well, I don't know, version 1.13 or 12 or 11, right? And then constantly updated it.
Okay.
But you watched closely, you saw it. So Mathis, you say, can you combine the hardware nodes with cloud nodes? Well, technically, yes. But what you would need is kind of a bidirectional communication, so that it kind of depends where the master is. But in theory, if they can reach each other, if those cloud nodes can reach a master which is on the hardware, or the other way around, I don't see why combining hardware with cloud nodes wouldn't work. What you could even do is combine those two. I mean, what I just did is install two different clusters. I installed a cluster on the NUCs, and I installed a cluster on the Raspberry Pis. I mean, what I could also do is kind of build a 10-node cluster, and then it's kind of a mixed cluster, right? So I have 5 Intels and 5 Raspberry Pis. But what I would need to do then is kind of probably work with node labels and taints, so that the correct container supporting the right architecture is scheduled on the right hardware. But a combination should do the job, should work. Adrian just asked us, but that would mean that the Kubernetes master on the cloud is managed by yourself, right? Exactly, right? So you would have to use MicroK8s or K3s. So what you could not do is, I don't know, spin up an Amazon EKS and then join K3s nodes. I don't think that would work. Yeah, it would be funny though. Yeah, that's true. I mean, maybe you can give it a try. Maybe you can give it a try. There's enough food for playing around in the GitHub repo. So feel free to spin up a Google Cloud and join a few hardware nodes, or maybe join your local machine to the cloud or something like that. But again, and that's the fun and the beauty of it, right? Because it's so easy to play around with those things, because installing it is just a matter of typing a few CLI commands, or having a makefile, and that does the heavy lifting, so you don't have to type that much anymore. Oh, see, I switched back here. You see, this time it came a bit further, so this time it already installed the master, so it's still running. And it's still on the, that's kind of the 2nd or 3rd Raspberry Pi. So you see, if on the Raspberry Pi, we don't do it in under a minute. But still, right? It takes some time, because it needs to download the binaries and then install things. Yeah, my pleasure for the repo. No problem. And if you want to buy this this carrier board. Let me see. I mean, I don't work for them, but that is Mini. No, I think this is called Mini Nodes. Mini. This one here, right? So this is the Mini Nodes ARM service. So if you want to build one of those clusters yourself, you can buy one of those carrier boards here from those guys. It does cost a bit, and what I'm looking for is that this is what I showed you the demo today. So this is what is currently running on. That's nice to play around with. So, if no more questions, I would say enjoy the rest of the conference. Enjoy the next talks.